Welcome to Lesson 18, Exercise 1, and here we have learned that light speed is 186,282 miles per second. That's an incredible number, miles per second. That's how fast light moves through the universe. Write a program to calculate how far a light beam will travel after 300 minutes and output the results to the screen. Note that the answer will need to be held in a long variable. And why do you think that's the case? It's because it's such a big number. And after 300 minutes, when you calculate and multiply everything, the number is going to be too large to fit into an integer. And we'll kind of play around with that and show you a little bit more why in a minute. Anyway, here is the code that we have. Inside the main method, we're creating a long variable called distance. That's what we're going to use to calculate the answer. An integer is minutes because it's just 300. That's given in the problem. And then distance is going to be the light speed, 186,282. times the number of minutes times 60. Basically, the minutes times 60 is calculating the number of seconds. So 300 times 60, that'll be the number of seconds, times light speed in miles per second. We're going to get a distance in miles, and we're going to output the distance traveled is, however many miles the distance is, and then the word miles. And you can see that I've already run this down below. We can save it, and we can run it again. The distance traveled is 3,353,776,000 miles. Very, very large number. This is a number too large to fit into an integer. So let's play around with this a little bit, and let me show you a couple of things about it. First, I'll get to this L in just a minute. I'll show you what that means in a minute. Let me take this long, and let's pretend we didn't know that, that there would be a problem. Let's create an integer called distance, and we're going to do the same calculation, except the answer is going to be held in an integer. Let's see what happens. We'll hit run. The distance traveled is negative miles. Now, we know this is an impossibility because when you're multiplying a positive number times a positive number times a positive number, there's no way it can be negative. If you get nonsensical answers like that, where you're doing crazy multiplications, especially with big numbers or very small numbers or very large negative numbers, and you get a sign that's crazy weird, then it just means that you've exceeded the range of your variable. The integer can only hold a number so big. Whenever you start calculating numbers larger than that, then what happens is things start getting truncated, the sign bit in the front of the integer starts getting used in weird ways, and so you can end up with a negative number that doesn't make any sense. So this is your big clue that your calculation was too large to fit in there. So the next thing that you might do is you might go up to distance and say, well, I don't need an integer, I need a long variable, because we know that those can hold much bigger numbers. And so we'll rerun it again, and notice the same answer appears. Now, this is where most people are going to throw their hands up and say, well, what is going on here? Because the distance is a long variable, so it should be able to hold long numbers. Why is this happening? Well, you've got to look at what Java's doing behind the scenes, and I admit it is a little bit confusing. This calculation here, on the right-hand side, 186,282 is just a number. We call it a literal that we're typing in. This number 60 here is also a literal because it's a number that we're typing in. Now, the default literal for integers is the integer type. So even though we want this calculation to give us a long result, when we do this, this is small enough to fit inside of an integer. This is small enough to fit inside of an integer. Minutes right here is an integer. So since this is small enough to be an integer, this is an integer, and this is small enough to be an integer, when Java does the calculation on the right-hand side, it's going to kind of treat it all as an integer. Even though the variable that we want to store it in is really a long, Java doesn't put two and two together and say, well, they really want to do this as a long calculation. See, it's trying to save memory when it can. And when you do all the calculations in terms of long variables, it takes more memory. So yes, we did declare a variable that's long, and that's our intention to store a big number there. But on the right-hand side, all of the stuff that we're trying to calculate involve pretty small numbers. So it's going to try to do them implicitly as integers to save memory. Well, we don't want to do that because we know that the answer is going to be too big. So what we need to do is tell Java, treat the right-hand side calculation as a long times a long times a long, so that we'll get the big number that we want. And the way to do that, this 186,282, it is small enough to be an integer, but we want to force it into being a long, so we put an L there. That's what that L is. This tells Java that the 186282, don't treat it as an integer type. Treat it as a long, which means set aside more memory, more memory space for that number than is really required. Now when we do the multiplication, even though it's multiplied by an integer and multiplied by another integer, because there's at least one long variable in the calculation, Java will treat the whole thing as a long. So when we hit save and we run it, we're going to get the correct number. So that single L here is what did the trick for us. Now notice if we delete it and we save it and run it again, we get our crazy answer. We can do the same thing to the 60. 60 is definitely small enough to fit inside of an integer, but if we just put the L over there, we took it away from here and we added it over there, it's telling Java, hey, this is a long, and since we have at least one long in the calculation, it's going to treat the whole thing as a long and give us the correct answer. So you can basically put an L anywhere next to a number where you're trying to tell Java treat it as a long calculation, and it'll work. There's one more way in which you can do it. We take both L's out, we rerun it, we get our crazy answer. In front of the calculation, we're going to get into this a little bit later as well, but if I put a parentheses and type the word long and put a space, that tells Java, it's the same thing as putting an L right here. It's telling Java, treat this number as a long. And then because we have at least one number behaving as a long in this calculation, then we should get the right answer. So they're all different ways of doing exactly the same thing, and that's why I'm trying to show you this, because in programming that's frequently the case. You can put an L here, you can put an L here to force it to be a long calculation, or you can explicitly cast it. This is called casting this number as a long out here and achieve the same result. In all cases, you're just trying to tell Java at least one number in there, and I could put an L over here if I wanted to. At least one number is a long, do the calculation as a long, so I can get the correct answer. So this is how you do this problem. Now keep in mind that 99.9% of the time when you're dealing with integers in Java, you're going to use the integer type. Only when you have very large numbers would you need to use a long for that. So all of this business is pretty rare. You're going to have a specific instance for when you might need to do this. It's just when you have very, very big numbers. So don't stress out too much about it, but this is how you tell Java to treat things as a long when you're doing calculations.